Hi, it's Mr. Baker here with another physics video. This one's about geothermal power. So, geothermal power, how can we make electricity from hot rocks? So this here is a geyser, and I don't know if you know how it comes about, but basically the water underneath the surface there is heated up, and it's heated up so much that the pressure builds up and then it bursts through like that. So it's these hot rocks that are underneath the Earth's surface that allow us to have the energy resource that is geothermal power. So let's have a look at that first of all. So this is the Earth, and the Earth has many layers. We've got the crust, which is where we are walking around on, and then just underneath that there is the mantle. Now the mantle is kind of like a solid and a liquid put together. It's kind of like the melted rocks, and because of that, then it can move around. Then underneath that, you've got the outer core. The outer core is a liquid; it's liquid iron, and then in the center is the inner core, which is a solid. It's the same stuff as the outer core, pretty much, apart from because of the pressure of all of that weight of everything above it, it's actually a solid. And you can see the temperatures that we reach. We go down to the bottom of the mantle there, which is about 4,000 degrees, down to the core, which is about 5,000 degrees. So the center of the Earth is probably in excess of about 5,000 degrees. And the heat that is there really is formed in three ways. So when the Earth was actually made, it was very hot, and so there's still a little bit of leftover heat from that. So the second way is through frictional heating caused by denser core materials sinking to the centre of the planet. And then the third type is from radioactive decay. So towards the centre of the Earth there is radioactive decay and heat is produced from that. So we found out that there is heat underneath our feet. So how do we tap into that to actually make some electricity? How do geothermal power stations work? So here's a diagram of a geothermal power station, and we can see some different numbers. So I'm going to go through and explain what each of these parts are. So number one here on the left hand side there, that's cold water being pumped down to the hot rocks where the water gets heated. Then they get heated up into steam, and the steam then gets pumped back up to the surface where it drives a turbine and makes electricity, and then that is fed into the network. Hot water is then also used for heating, so we've got a load of hot water that we haven't used for anything else, so that can be used for heating, and then steam is condensed and so it can be reused, and so it's like a cycle. So what are the good things and what are the bad things about geothermal power? So one of the advantages is that there is no fuel required. It's reliable. It's got a 24-hour power production, and the power stations have got long life. And there is no carbon dioxide produced because we're not burning anything. Disadvantages are that it's dependent on the availability, dependent on the place, so geographically. So not all places, you can't just dig down into the ground and find hot rocks that enable you to have geothermal power. So specific places will have a lot, and other places won't have any. It can't provide all the power, so it's not a big enough amount of power that we can use for all of the electricity needs that we have, and they're expensive to build. Right, so this is what we've done today. You should be able to describe how electricity can be produced from geothermal energy in the crust, and you should be able to describe the advantages and disadvantages of geothermal energy. Right, so geothermal power, how can we make electricity from hot rocks? Hopefully you've got a better idea of it now than you did at the beginning of the lesson. And that is pretty much it. So thank you very much. I've been Mr. Baker, and this has been all about geothermal power.